Assalamu alaikum and welcome to another Unity tutorial. In this tutorial, we will learn how to use Unity Netcode for game objects. We can say it is a multiplayer, Unity multiplayer tutorial for beginners. So this will be absolute beginner guide. So if you are already familiar with Unity Netcode for game objects, then we can skip this video. Otherwise, if you are new and want to know that how to work with the Unity multiplayer using Unity own netcode solution. So remember, there are other solutions as well, like Unity Photon and Mirror. They are the third-party solutions that you can also easily integrate into Unity, but this tutorial is about Unity owns netcode for game objects, which is also called NGO. Well, I have this Unity 6 project open. It is almost an empty project with default URP settings. There is no extra fancy setting in it. Just we have a plane and we have a cube that we can move move and rotate using this simple script. And this is a very old script. I will say that it's just using Unity old input system and just taking the horizontal axis and vertical axis from the keyboard WSD to move and rotate the cube. It's just for the demo purposes. So if I run this to show you, use WASD. Okay, so this is the basic setup, and you can see this is almost empty project with some default Unity URP settings. So now let's get started the multiplayer setup here. And for this reason, first of all, we need to go to Window, and here you will find Multiplayer and Multiplayer Center. So what is Multiplayer Center? It is just uh, it is just a configuration window to set up Unity multiplayer, or you can say that it will provide you a facility to install multiplayer setup or its packages while providing a guide. So how this guide is work? If you go to game specification section on the left side, there are the genre of your game object, that what kind of game or game you want to make for this project. So this has different option available. For this game, we can set to any type because it is our first Unity netcode for game object project. So we can select any type, but for better recommendation, you need to properly select the type of or genre of your project. So let's say we are using racing, and the second thing you need to tell that number of player per session. So how many player will play? So let's say we can call it to 4 or 8, right? And as I will click this, it will recommend me what kind of setup I need to do for this project. So if you can see, there are some other options as well. So I will say that leave it as it is. And we are using the client server architecture and just a default setting. You don't need to worry at this stage, and just focus on the recommendation setting. I want to show some important information here is that you have as you select this type of the genre, it will recommend you what kind of package you need to install. So it is saying netcode for entities. So remember, netcode for entities is an advanced topic because it will utilize non-object oriented structure, data structure, which is called dots. Or sorry, so you can in simple terms you can say it is a dot architecture. So this is for dots architecture, and it is for advanced users. So at this stage, you don't need to go with this. Instead, you need to go netcode for game objects. Actually, Unity recommend this for cooperative game, not for competitive games, but you can run this using the netcode for GameObjects for the moment, and it will work well. But if you are an advanced user and you want to get very good high quality results, and scalability is also your issue, then you may need to check to the Unity netcode for GameObjects. So sorry, netcode for entities. It is for advanced purpose, and it has a data oriented stack, ACS or dots, and it is optimized for high performance games. For smaller games, suitable games on object oriented structure, we can use netcode for GameObjects. So this is one of the important things that I want to show on this window. And if you can see, here's a hosting model, dedicated server, recommended, client hosted, and you can leave this is as it is. So leave this as it is. So, and you can see there are some other recommendation as well. And for this tutorial, you can see this is non-checkable, which means we have to install this netcode for GameObjects. This is the core package that we will use to develop multiplayer game in Unity. And there are other tools that you can uncheck and check according to your requirements, but I know that you are not familiar with all, and so I will say that leave as it is. And I just want to give you some overview about some of the things, like for voice text and chat, you can use VVox. So we are not using currently voice or text chat, so we will uncheck it. So this package will not be installed. And Unity multiplayer tool, this will allow you to debug multiplayer gameplay. This is very helpful tool. We will see its demo in upcoming tutorial. So I will say that to install this, and we have multiplayer services to this is for matchmaking in lobby system. And while this is some experiment rapidly multiplayer services, which we'll see in this videos, and this is also multiplayer play mode. This is one of the I will say the most important package for this tutorial, at least, that this will allow us to test the multiplayer project within the editor using different clients and server. So we can use this to, without deploying application, we can open different windows for our games and test in a multiplayer setup. So this is very helpful. So as I will click install packages, it will install all these packages. And let's okay this. It will take a bit of time, and then install all the relevant packages that we have selected here. All right, so our recommended packages are installed now, and you can see some guidance for the multiplayer is also available here, and there is nothing important for the moment. So let's close this window. In order to verify that our packages are completely installed, you need to go to window package manager, and you can see we have this multiplayer packages are installed now. We can do this directly as well, but the multiplayer center is a handy way, and you can see there are other options are also appearing here because we have installed other packages. Okay, so in order to make our scene networkable, or at least we need a base class or a configuration class that need to handle the network connections and network requests, and for this we need a component. So let's create an empty object, and we will call it network manager. So as the name suggests, it is our network manager, a singleton that we need to create a multiplayer project. So this are the basic setting. You just leave as it is all the settings except the transport layer, that how to transport the network. So for this we will use the Unity transport, and Unity transport is allow us to send the packages and make the connection to a port and address. And for this demo, we are using the default address import. It represents our local system, and there are some different other settings like encryption and time payloads. So I will say that leave as it is. So this is our network manager for singleton, and that need to require, because it will has start host, start server, and start client features. In order to make connection with other player, we need this. And Unity transport is definitely for the transport of the data. So these are the two essential components at the moment. Okay, so now let's go back to network manager, and there we have an important variable which is called default player prefab. So as a host or a client or a server a host or a client start the player or join the player, an object will be instantiated that we need to put here. So in order to put an object on the player prefab, we have to prepare it for the network. And in order to preparing this for the network, we need to add a specific component which is called network transform. Sorry, this is the network. This will be introduced. It will be called network object. So in order to share this object's behavior or states throughout the network to the server and different instances, we need to make it networkable. So this is required. This is the network object, and we just need to make a prefab of it so that we can assign it into our network manager. Let's create a prefab folder and just put this here. Go back to our network manager, and we just need to drag and drop this cube here. So this is the very basic setup. Let's save this, and now it's time to run this. And before running this, let me first run this. Wait for a while. We just forget to delete this game object. We don't need this at the moment because we now want to instantiate it. Let's play this again. You can see we have nothing here, and we just want to start the server. So we just need to select network manager, and here we have three buttons activated. So host meaning that we are using server capabilities plus the player, and the server is a dedicated server, and the client is the is a client which don't have the server capabilities. So we will use a start host, and it will instantiate our game object here. So this is our game object. Obviously, we can play it and run it. It will work accordingly. But now, how to test the other client with this host? So in order to make the other client, one traditional way is that we just need to build and use some forms to connect with this host. But as we have installed different packages, and if you go to window multiplayer, we have this multiplayer play mode option available. So if you click this, it will provide you 3 players functionality. So you can use along with the main editor, which we can call it client or server, and along with that you can use 3 player as well. So let's just enable 1 player, and it will activate the same window like this for your player. This window will allow you to test client and server. So it is a very handy way, or a convenient way to test. So you can see we have the second player available here, and it has a game view as well and a console as well. And we want some more windows here, so we will go to the layout, and here we can so it is a client. We can add Let me first play this. And we just need to focus this as well. And here, as I play this, you can see there are other options available as well. For example, hierarchy and inspector. So let's apply this. So you can see now we have access to player 2, hierarchy, and its inspector as well. So now we are running this. Okay, so let's close this first and just go back to our second player as well. So this is our editor player and this is the another player. Let's go to network manager and start the host. As I start the host, it's instantiated the cube, our main player, and then I go back to our player as well. Let me just it. And now we will go again to the network manager, and here we just need to start the client. And as I click the client, you can see my client is also appearing here. But if you can see this, all the objects are working at the moment. That you can see that there are two objects, and if I click, both objects are moving simultaneously. And if I go here and just add the scene part here as well, you can see that both cubes are working here. There is no synchronization across our different scene. These are two independent things. Why is it's happening here? Because when we instantiate the player using the network manager, you can see both scripts are on the client side and as well as on the server side. So they both scripts are consuming the input. So the first thing we need to do is to restrict the input for the particular game object. Like if you have instantiated this game object, then the control of this object should be on your side. While if the client is connected, then its own cube or on player input access will be on the client side. So let's unplay this and go to script and create a script which we can call that player party. But this will be my script. So we clear this here and we can use network behavior here. This is the part of network unit code. So this is some kind of like a base class that allow different functionality to you. For this, we will use override on network specific. So we will use this own network spawn, and here we just need to make sure that if this is the owner, then we should need to restrict the access. So let's say if it is owner, the get component, we create two other ones. Pause. This is a dashboard actually, which we can choose later. Yes, attach this is first. Let's just go to cube and attach this first. Set player and party. And you can name like so let's play this to see if it's working or not. Let's go to the network manager and just start a host. It is activated well, and then go to good. Manager. We need to instantiate right. Then we go to the queue. So working. This working perfectly. So this is the server side, which is deactivated, and this is our it's deactivated. So you can see if I provide the input, it's only now moving the client queue or client will. This is the server side, so it is not. It is moving its own player instance. So this is clear, but there is one more caveat. If you can see this, the things are not thinking across the network. Like if I'm moving this player, then my client side cannot view this movement here. And likewise, server side movement or client side movement is not appearing on the server side. So if you remember, we have set this view with network object to make it networkable, but it does not mean that it will also reflect its changes. I mean, it can reflect, but there are some other components that you need to attach with your prefab. Let's go to prefab and cube, and here we have network transform. Network transform. Yeah. So this is the component provided by the netcode. So it will allow you to sync its position, rotation, and scale. And there are some other settings as well. And for the optimization purposes, I will say that only sync those things that are necessarily required to transfer over the internet or you want to share over the internet. So let's say we don't require scale thing, maybe X and Z as well. We only require the Y rotation. So just pretty neat and simple. Let's run this again. Just go to network manager, start the host. The other part, we just need to go to network manager again and just associate the client, right? And just move this here so that you can see. Let me adjustment here so you can see. We can, as I am moving, the movement is synced across our client So right now on the server side, right? But if I go to my client side, I cannot move it. Not even I can move it on the client side as well, because we don't have the authority, despite the fact that our script is activated on this object, right? But we cannot move it. The reason is that we don't have the authority, and the server is just overwriting its position. So whenever we make a change from the client side, it goes to the server side and validated, and then it broadcasts to other clients. But at this moment, we don't have the authority, so we cannot move it. So there is a short and simplest way to do this, which definitely has some trade-offs. And but for this tutorial, we will follow this. So let's create a script which is called override authority. Let's open the script, and here we need to extend the network transform. We need to extend the script from the network transform, right? And here we have override, and here it is the OnIsServerAuthoritative image. We just need to return false. We OnIsServerAuthoritative, we just need to tell them false. This event will allow us to make our client work. Let's compile this and just go to Prefab, go to Queue, and we will remove this network transform, and we will attach our own override authority, which is also the form of network transform, and we'll just do the same. So let's save this as well, but not required to save. Just run this. Network manager. Here we need to start this. Let's move a bit to our layer 2. Let's go to network manager. I'm going to start the client. If I move this, I can now move it. And meanwhile, you can see it's working. It's working on the server side as well. So the network transform is syncing across the server. And likewise, our client side, or our server side, is also reflecting on the client side. So this is a short tutorial, but remember, we have used this override authority. I mean, we used a network transform with OnIsServerAuthoritative to false. We don't make the server authoritative, which it has a problem, because this will allow hacking and cheating. So this is not a secure way, but a way to proceed with this problem, or to solve this issue. So using this OnIsServerAuthoritative override, we have tell the network or the network transform that we are transferring the authority to the client, because by default network transform operate in server authoritative mode, and by default the network transform operates in server authoritative mode, and changes to access are directed on the server side and pushed to the connected clients, and that's why it's resetting. So we just created this code, and we transferred the authority from the server to the client. So allow the client to control its own transform. And obviously this has a drawback. As I mentioned earlier, it can create a problem for hacking and cheating.